firstly, I just want to say welcome, all 300 of you. I am enormously gratified that you're going to give me and this topic an hour of your time this morning or this night. If you happen to be in India, I saw one of you is burning the midnight oil over there. I just want to say welcome and thank you for joining us. I'm going to begin right away by giving you a map of this conversation. I'm just going to sort of geek out on you right off the bat and give you this little time series that describes how I want this to work. Here's where we are right now, where I'm welcoming you, and in 30 minutes from now, we're going to cover, between now and 30 minutes from now, we're going to cover a whole bunch of stuff that's going to range from very sort of high concept, theoretical issues in histograms and cleaning data, all the way down to the in the trenches implementation of the types of topics that I'm getting ready to teach you. Just so you know, I want to make this very clear. What I'm doing in this presentation and in my work is geared towards people who are starting off learning about data. One of you mentioned in your comments that you're hoping for the presentation that would be for data analysis for English majors, and that's precisely who it's for. If you're a PhD statistician, then I think you may find some of the stuff in this presentation elementary, but you're very welcome even so. Here's me. I'll just tell you very briefly who I am. As you know, I'm the author of Head First Data Analysis, and I'm currently writing Head First Excel. Before I became an author full-time, I spent almost all of my time staring at databases of nonprofits to try to figure out what to do strategically with nonprofit businesses to raise more money from their donors. And one of the scenarios we're going to describe today is all about that, so I won't elaborate here. I have a whole lot of really useful people that I want to, useful and important people that I want to mention who are supportive of me in this work. One is Brian Sawyer, my intrepid editor. Equally intrepid is Brett McLaughlin, who is my editor and sort of an editor of editors, and also my good buddy here, pictured in Mongolia, the statistician Blair Christian. All of these people keep me honest, and if there's anything good in what you see, it's probably because of them, and any problems are my own. A few more housekeeping items before we actually start talking about histogram. What I'm trying to do with Head First Data Analysis in Excel and the other work I'm doing with O'Reilly, as I mentioned, is trying to bring data skills to everyone, because we believe that statistics and computer work and all these types of data skills, if you don't know them, it's not your fault, it's the fault of your teaching. The problem is not that it's hard, the problem is that it's hard to teach. And with Head First and all the work that we're doing, we're trying to make all that heavy stuff really palatable and fun and engaging. Here's a list of the things we cover at Head First Data Analysis. It's a big survey of all of the different key disciplines of data analysis today. Ranges all the way from the high concept to the gritty and practical, and it tries to make stuff as realistic as possible. I'm showing this to you now so that you will take note that histograms and cleaning data are both chapters in Head First Data Analysis, so if you're interested in investigating these topics any more in depth after today, there's a great book for you that you could use to do it. One last thing, I really need your help to know what are the technologies, what are your problems, what are the things that you need to get better at, what are the things in regards to data that you would like to learn. As soon as I get off this, I'm going to continue writing Head First Excel. The more information I have from you in terms of your objectives, the better content I can create. So please send me a direct message on Twitter. This is my personal email address. Send me an email. I really, really want to hear from you because it's all about you. So let's do some histograms. I'm going to start off with a fundraising problem because that is my personal area of expertise. Let's say that we have a data set that we've received from Charity X. We received a big export of last year's gifts. And the problem that we want to solve is what's up with our customers. Now that may seem like a very vague problem. Not data analysts solve really small problems, and what's up with our customers might seem silly and vague, but as you'll find out in a few minutes, whenever you're looking at a new data set, you want to ask these high-level questions like this just to try to figure out what's going on inside of the data. Here's what the data might look like. I'm sure you've all seen spreadsheets like this. This is a set of data that I just worked up that lists from last year's donors and gifts amounts. And there's 1,350 records in this database, and so it's not a set of data that you can just look at and suddenly grasp what it is that's going on in it. Unless you are, have some sort of computer in your brain, chances are reading 1,350 rows of data is not going to be terribly illuminating to you in terms of understanding what the big trends are inside of that database. So what we need to do is figure out ways to summarize that data so that we can understand what's happening. So what are some ways we might want to summarize it? Well, the first and most obvious way, the thing that I would do if I were looking at this data for the first time, would be just to add the transactions together, figure out how much money did this charity get last year. And you can do that just by creating a simple sum formula, which I hope many of you know how to do in Excel. Catherine, are you there?
Yes, I am.
I keep hearing this like low piano note being hit. Is that the WebEx?
Other people have mentioned that before, and as far as I can find out, it's something that is not everyone can hear. It's something either on your phone or your computer system, or we haven't been able to replicate it.
Okay.
Okay. Sorry about that.
Yeah, I just wanted to make sure that everyone was still here and could hear me.
Oh, yeah, we hear you fine.
Great, thank you. So the first thing we might do is just add up all the gifts, do a sum. But, who really cares about that? I mean, if we're trying to do data analysis, chances are the charity already knows how much money they have. That single metric of how much money all the gifts add up to doesn't really tell us about anything about the individuals, and it as I say, just doesn't really pass the who gives a crap test. So it's not really saying anything interesting. Another obvious thing we might do would be just to get the average gift. I mean, that might tell us more about what individuals are doing in this last year when they made their gifts. And you could create, an average formula and take a look at all of the gifts in column B, and you'd see that the average would be just, say, $271.37. So the reason we would look for a statistic like this is just to try to figure out what's typical, like if you just randomly pick somebody, what is the gift that they were likely to give? Or at least we might think that that is what an average would represent. But once we got the average, what we got to do is we just want to look at the data and see if the average even compares to the data. And we might find that most people are below average, and nobody actually has the average. And so our question, the question that if you read Head First Statistics, you would already be prepared to answer is, what kind of metric would help us figure out what people's behaviors are. I mean, this average doesn't seem terribly useful to us because nobody has it, and it appears that most people are actually below average. I mean, whatever that means. We'll take a look at a second at what that means. How do we just like throw every Excel formula we have at this problem and maybe tell us something we don't know? Well, one approach that would summarize things in a way that would keep it simple without keeping it so simple that it tells us nothing would be just to look at different subgroups. So we might ask, for example, how many people gave between $0 and $10, how many people gave between $11 and $50, and stuff like that. And so that's what I've done here. Like I've stipulated a gift range between 0 and 10, 11, and 20 and counted the number of people in those buckets. Or rather, we're going to call them bins. Binning is a big deal in statistics and in histograms. So instead of looking at the whole list, we could divide the list into bins and see how many individuals fall into those separate bins. And what it looks like here is that we have a whole bunch of people, or I guess 11.2% of people who are giving small gifts. And it also looks like, we have not terribly many people giving between $11 and $100. And then when it comes to $101 to $500, we have a whole bunch of people. So by looking at this subsetted list, this collection of bins, we definitely get a better perspective on what's going on under the hood inside of that data. So this is pretty useful. So the next step that we would want to do in order to make a histogram would be to take these bins and represent them graphically, because even though it's, this is a small enough list of numbers to be something that we can read and make sense of, it's always a good idea just to chart this stuff into a histogram to see how it is represented in that format. So this is the histogram. And this isn't terribly useful. I actually went into R and told R the bin amounts, and it gives us all these blocks of different lengths with different heights. Now, why would these blocks be all of different lengths? Why would it not just be like a regular bar chart that shows, one bar for each bin? Well, the reason is because this is a continuous range of numbers down here at the bottom. And so the bins, from the perspective of the size of the donation, are of very different sizes. And so what the histogram does is each little block represents a bin. And the different sizes of, it's actually different sizes of the bins, the different sizes of the blocks, represent the different sizes of the bins. And so together, this whole area represents 100%, it's actually the area more than the height of the bars that we want to be looking at. But like I said, this is kind of a crummy histogram. So let's rerun the histogram, but this time instead of stipulating our own bins, we can use R's function to stipulate its bins. Now this is something that looks a lot more palatable. This is R's histogram version of last year's donation data. And like I said, it's not the height of the bars so much as the height and the area of the bars that represents different percentages of people in our database. So the bins that are created automatically are in $50 intervals from 0 all the way up to, I guess, about 2,000. And what we know here is that we have approximately 180 people who gave in this 0 to $50 range. And here's our hump in the middle, which actually gets quite high. So by looking at the area of these bars, we can see where along this range, in terms of the donation size, people concentrate. Like I said, there are 158 donors here in the 0 to $50 range. Just so you know, the average amount that we calculated several minutes ago falls around here. And I think that looking at the average in light of the histogram shows how, frankly, useless the average is for us by itself. Most of the elements are concentrated in the histogram below the average. And the reason the average is drawn over to the right is because we have this long tail of observations of people, of small amounts of people who gave large amounts of money that's kind of pulling the average over. Now, what our next step to do with this histogram is figure out, okay, how do we interpret this thing? We've got all these humps. What do they mean? Because if you recall from the beginning, what we're trying to figure out is, like, what is up with our database at the highest level? What are people doing? What were their gifts last year? And how do we make sense of that? So when we look at these different concentrations of people along the donation range, there are humps, and these humps are there for a reason. Like, something happened in the real world that accounts for these humps. And so one of the things we might do, for example, if we're interviewing the person who collected the data, would just be to ask them, like, why do you think it's like that? And there's generally going to be a good explanation. Maybe they know it, and maybe it's your task as a data analyst to figure out what the reason is. If it did fall on you to figure out, like, what is the reason for all these humps? Like, why are there people concentrated giving small amounts of money, and then a larger concentration giving a medium amount, and then a small handful of people giving large quantities? One way you might start would be to simply split up the data into even smaller groups. So we're grouping people in terms of their giving levels, but we could group them in terms of other variables too, like their age, for example, and then look at the histograms to see what different categories of people, how their bins compare to other different categories of people. So, like, let's say we'll just do that. We'll take the grouping age and draw a histogram just for young people. So if we commanded tilde R to draw a histogram that contained just young people, and this is a typical thing in fundraising, you might have a very large spike here on the far side, and no activity over here with large amounts of money, because young people don't give large amounts of money, but maybe you have a whole bunch of young people giving small amounts of money. And so if you would compare this to the regular histogram by splitting it up into age groups, or at least into the young age group, you would have shown that this group over here is largely accounted for by the youth presence in your fundraising program. Now that itself might have a reason, and it would be a matter of detective work to figure out what that pattern is. So, and typically in fundraising, the reason would be that there are special youth giving programs that will attract large numbers of people at small giving levels. This is just sort of an example of like how you would take a data set, use a histogram to figure out like what is the topology of that data set, and then dig a little bit deeper into it to try to figure out like what accounts for those peaks, the rises and falls, the peaks and the troughs. Histograms are useful for exploratory data analysis. I would suggest strongly that histograms be one of the very first things you do when you look at a new data set for the first time. When we say exploratory data analysis, that means technically a type of analysis where you're looking for hypotheses to test in a deeper way. So it may be that the youth fundraising initiatives are causing the increased participation of young people at these smaller giving levels, or it may be something else. As part of exploratory data analysis, you're looking for questions like that you could test later rigorously with more powerful statistical tools. So,
hey, Michael?
Yes, please.
This is Catherine. I'm sorry to interrupt, but I've had requests from the audience. First of all, two things. I since found out you asked about the beeping. It's new messages in the chat room. Because you have your chat window minimized, you get a little beep each time, so no one else is hearing that unless they also have their. And the second thing is, in the lower right-hand corner of your screen, you have a panel, your tool palette, and to everyone else it appears grayed out. And people are asking if you could move that either off the screen or somewhere else where it doesn't cover the text. That's perfect. Perfect.
Like that? Okay.
That's great. So thank you.
Okay.
Carry on.
Should I change I can make my volume go down. That way you won't hear the piano. Okay.
We don't hear it at all.
Okay. Well, okay. There you go. Cool.
Okay. Thanks.
All right. Awesome. Thank you for that. All right. So before we actually implement some histograms, let's go really quickly to look at some real-world examples of histograms. If any of you do digital photography, then you're probably aware of how histograms are used in digital photography. So here's a picture of my dog, and let's say that this is what I see when I'm trying to take a photograph, and my goal is to set my camera settings correctly so that it takes the right picture. It takes a well-exposed picture. Now, this photograph is really just a collection of pixels. At the heart of it, this photograph is from an 8-megapixel camera. It's got 8 million pixels, and that is the data. And if we take a little area like the side of his nose here and zoom way in, we can see all of those pixels. Like here's Preston's nose, like this little black part here is the corner of Preston's nose. And in fact, this is still in color, and I'm just going to drop out all the color here to show black and white. One of the pieces of data that photographs contain, that each pixel contains, is a value that ranges from 0 to 255 to describe the brightness of that photograph. 0 is pure black. 255 is pure white. So when you take a picture, that picture is a very large data set of luminance values from 0 to 255. And those values can be plotted on a histogram to help you figure out whether you're getting the right exposure. So as I say, here's the photo we want. And let's say we take it, and this is what our histogram looks like. Now, because there's a continuous scale from 0 to 255 at the bottom of the histogram, 0 would be over here, and that would represent black. And it doesn't look like there's a whole lot of pixels represented in the black. White would be around here at 255, and it looks like we've got a whole bunch of pixels sort of jammed up against the white. So our question is, does this histogram represent a well-exposed photograph? So let's look at the photograph that corresponds to that histogram. And it's way blown out. There's a whole bunch of white, which you can see here in the histogram. All of the white pixels are sort of jammed up against the side. Let's take another photograph, changing our exposure settings, and we get this histogram. This histogram has a whole bunch of stuff, a whole bunch of pixels concentrated over on the darker side of the screen. So maybe that'll come up with a better photograph for us. But if we look at it, we see, look, there's all this black here. The histogram doesn't represent the color, only represents the brightness of the pixels. This photograph is underexposed. So think for a second, what do you think the histogram should look like? Well, basically all of the pixels should be concentrated in the middle, not too dark and not too bright. And this is the histogram for this actual photograph. So experienced photographers will often, when they look at their photograph after taking a picture, not actually look at the image, but look at the histogram to try to figure out whether the exposure was correct. If you have an SLR camera, this is one of the things it can do. So let's look at another one. I read this poll from Gallup that shows some histograms. It's actually a report of several polls that came out very recently. And their conclusion was, overall, was conservatives maintain edge as top ideological group in the United States. But I want to draw your attention to this little subsection here, which I'll blow up. They discovered, or they concluded, that there was an increase in conservatives among independents. So what they did was they went out and surveyed Republican, independent, and Democratic voters and asked all of them whether they consider themselves conservative, moderate, or liberal. And what happened, what they discovered was that between December of 2008 and September of 2009, the conservative, moderate, liberal composition of the people who are Republicans and the people who are Democrats are pretty much the same. But among independents, there are now 35% of them consider themselves to be conservative, whereas 29% of them in December of 2008 considered themselves conservative. For those of you who are not Americans, what the independent voters think is the whole game. It is a very, very big deal, so politicians are paying attention to this type of data. Let's take another look at another histogram. This histogram has a few little problems with it that I'll ask you to think about as I'm explaining it. An organization that I volunteer for is an advocacy group based in Austin, Texas called Texans Care for Children, and I do data work for them as a volunteer. And they pointed my attention to this report, which they didn't write, but that they used from the Texas Department of Family and Protective Services. And this just looks at the age of children in foster care in Texas. So there's a few things wrong with it, and just in the interest of keeping things moving, I'm going to point them out to you. One of them, which I haven't mentioned, is that it has all this redundant data. It says 3623 here, 3623 here. As you'll see if you haven't already read the chapter in Head First Data Analysis on visualization, less is more when it comes to these things. But also, there's some gaps between the bars, which isn't how histograms work usually, because this is a continuous scale of data from birth all the way to age 21. And so these gaps would tend to mean that there are individuals, at the border between these bins, or it would actually mean that there are bins with nobody in it, like people who are exactly 9 years old, there's nobody in it. So it's not a true histogram. Another thing that's kind of wrong with it is that the length of the width of the bars should be different according to their bins. So in the first two, they're children age 0, 1, and 2, age 3, 4, and 5. But in the third through sixth bins, there's 6, 7, 8, 9, 10, 11, 12, 13. There are actually 4 years represented in all these bins, whereas there are only 3 years represented in these bins. And that should be reflected in the width of the bars. There's not a lot of information in here. It's all pretty neatly summarized, so you can look at it, but and make effective judgments. But even so, it would be better if it were a more proper histogram. So let's make some histograms. I'm going to pop out of Adobe Acrobat here and go into Microsoft Excel. And I'm actually running Windows Excel inside of a Mac. So fear not if you use Windows. I'm going to use the Windows version even though I'm operating inside of a Mac. So the information that I have right here is something I got off the UN website. Actually, let me show it to you. If you go to data.un.org, they have all sorts of really cool data that you can look at for free that is collected from all sorts of public and government sources. And what I'm going to look at now is computers per 100 people in the year 2004. This UN data set has almost 200 different countries. And we would like to see what is the histogram for this data. On average, how many computers per 100 people do each one of these countries have? So to do that, we load the data, and we go to the Data tab inside of Excel and go to Data Analysis. Now, there's a chance, I think it's a small chance, but there is a chance that you won't see this. So what you should do is go to if you don't see Data Analysis as an option there, go to the Office button, click on Excel Options, go to Add-ins. You want the Data Analysis add-in, and then click Go down here, and it will give you the Analysis Tool Pack checkbox, and you can make sure that you have the Analysis Tool Pack when you have it, if you don't have Data Analysis already in there. But we do, and I don't think you need to use your installer disk or anything. I think it's pretty easy to crank up. So we go to Data Analysis. There's a bunch of different statistical operations that you can do, but we want to pick histograms, so I'll click OK. And here it was nice. The Data Analysis Tool Pack automatically gave me the range of the data that I want to look at. It also gives me the option to stipulate my own bins if I want to, but if I leave that blank, it'll create its own bins. So I'm just going to let Excel for now create its own bins and click OK. And here it gave me this histogram. And it's kind of hard to read. I have to make it bigger. So as you can see, the bins that it created were, I'm not sure what the algorithm is that it uses to create bins, but they're kind of weird. I mean, they're not whole numbers. They're these really long decimal places, even though otherwise it appears to be a promising histogram. So I think this is probably an instance where it would make sense to create our own bins. So if we go back over here, I'll just create a little column that says My Bins. And I know that the data range goes from, like less than 1 up to 90. So I'm just going to do 20, 30, 40. I'll do 10, 20, 30, 40. So I'll just, create my own bins like that. I'm having evenly spaced bins. Like we did on the last version of the histogram we did, just to keep it simple. Go to the same thing, Data Analysis, Histogram. It still has my data selected, but now I want to select the bins. Select the bins and click OK. Oh, can I empty the clipboard? OK, ignore that error. Everything's fine. So here's our histogram, and this looks a lot nicer. We got this legend here. We don't really need that. And all of our bins are easy to read and easy to understand. But there is kind of a problem here, which is that they all have spaces between the two of them, which, as I mentioned earlier, is not how histograms are written unless there is actual gaps in the data. So the way to get rid of the spaces in your histogram and make it a proper histogram are to right-click on one of the bars, and reduce your gap width all the way to 0. So here we go. This is a perfectly nice histogram created inside of Microsoft Excel. And as we can see here, the majority of countries are concentrated in this 10 computers per 100 people or less range. So on the list that the UN is using, there's probably a whole lot of poorer countries, or less affluent countries would be the better way to describe it, that have fewer computers per population, per 100 people. And over here is where we might expect to find the more, on the right, the more affluent countries that have more computers per 100 members of the population. So this is the distribution of computers across the population. Now we're going to also implement this same operation in the open source statistical program R, which I have loaded up right here. I expect that most of you don't have a lot of experience with R because it's kind of a niche product, but it's incredibly powerful and useful, and if you aren't already familiar with it, it's very much worth your while to learn R. R is written for and by statisticians, and so things like histograms, it does extremely well. So the first thing I would do inside of R, if you don't understand everything that I'm doing, that's fine. I just want to introduce this approach to you, and we can talk about details in Q&A if that interests you. First thing I want to do is create a data frame that will load my CSV file. And this is the command to do that. And the next thing I do is I would take a look at that data frame just to see what's in it. And I'll make this window a little bit larger. And the head command just shows me the first 10 rows, or the first 6 rows. And here it appears to have loaded the data into memory well. And what I want is this value column. That's what I'm going to make my histogram about. So the command inside of R is just hist. Computers $value. And that second expression just says grab the value column in the computer data array. And so here you go. R created a very beautiful, very elegant, perfect histogram. Just like with Excel, R tried to guess the number of bins I wanted to use, but if I wanted to specify my own bins, I could say, let's make 5 bins. It could do that very easily. I could make 100 bins. No problem. R is just very well prepared to do this kind of work. And if I want to create bins of different sizes that are not all equally spaced, that's also very easy to do in R. So you can see how quick and easy it is once you know 3 or 4 commands to create histograms in R. So I'm running a little bit behind, and in order to try to keep on schedule as much as I can, I'm going to just jump right into a discussion of cleaning messy data. So I'm sorry that I'm unceremoniously popping off of histograms. If you have questions, please submit them. We're paying attention, and we can do them in the Q&A section. Let's clean messy data. Messy data is a problem that plagues all of us, and I just want to point out what the big deal is behind messy data. The negative consequences for messy data there are a number of possibilities. One of them is that you ignore it. Ignoring data that you have that's otherwise useful simply because it's messy is bad. For obvious reasons. Another negative consequence would be if you have to retype the whole data. I've seen people do this a lot of times. If something's just so messy but they have to use it and they can't figure out how to fix it, they'll just retype it manually. That's almost always results in error, and that's a big problem too. And finally, having messy data that is used improperly can, in the worst case, lead you to the wrong consequences about whatever it is you're trying to study. When you're looking at data that you're contemplating fixing, you need to think about at least 2 dimensions, which I'm here call quality and noise. And when I say noise, I just mean basically the amount of garbage and crap that's in the data that you need to get out of it in order to be able to use it effectively. It's possible to have high-quality data with a lot of noise in it. It's possible to have very well, neat, organized, noise-free data that's of a crummy quality. So when you're contemplating cleaning data, you have to look carefully at what it is, where it's coming from, is it even worth my while to clean it, you know. And I've even had situations where I've seen people intentionally be deceived. Like I've been given the wrong data before in a very neat, lovely way, and I've had to look at it and conclude that even though this is really nice-looking data, it actually is a deception. You know, so noisy data is not necessarily low-quality data, and vice versa. But it's an important qualitative decision you need to make when you're looking at data. How do you get good at cleaning data? The only thing I can tell you is just practice, practice, practice. Learn as many Excel functions as you can. There are no sort of standard ways in which data is messy. Data can be messy in a million different ways, and so it's hard to sort of specify generic ways to solve the problem of clean data because the problem has so many different forms. But the best way to do it is just to spend a lot of time practicing and working on it. Before you get started, another very important thing, which all of my tech reviewers from Headfirst Data Analysis were really adamant about, is save your work, save your original work. Because when you clean data, what you're doing is taking an original document and changing it into something else. Also, write down everything you do. It sounds kind of excessively anal to have to write down every little bullet point, every little action you take, but you really are changing data, and you have to make sure that you have an audit or a log, because if something weird happens down the road, you want to be able to relate your data back to the original messy data in the clearest way possible. For your own sake or for the sake of your client or whatever, it's just really important to leave yourself a trail of breadcrumbs. So today I'm going to teach you two tools for cleaning up data, using Boolean formulas and using text formulas. These two tools won't clean all of your data, but they'll clean a lot of your data. In order to, and one last little thought, what we're going to be doing when we look at this messy data is look for patterns and use those Boolean and text function tools to exploit those patterns to kind of rip out all of the stuff that we don't need. All right, so let's go to Excel. And right now I'm operating inside of Excel for Mac, just because I'm kind of Mac-centric. And I have some real data. It's not the messiest data in the world, but it's messy enough to show you some of these basic principles. This is real data, and as I mentioned earlier, the organization that I'm volunteering with, which is called Texans Care for Children, is interested right now in consolidating a whole bunch of their information. And one of their problems is looking at their Facebook information. These aren't the actual names of their Facebook followers. It's a wonderful organization. I would suggest you become a Facebook follower of them, but I made up names just to conceal people's identities just in case. But this is stuff that I literally copied and pasted right off of the Facebook website, because Facebook isn't designed to give you a neat, clean export of that information. So what we want to do is, let's say our goal is to get data in a form so that it looks like this: Milton, comma, Michael. That would be a way of framing the data so that we could, sort it by last name, have everything stuck together. In order to get from here to this, we need to look at the patterns of the mess. And so, what is our, the first pattern that jumps out to me is that we have, 2 or 3 cells with data in it that we don't need for every one name that we have, because it's the names that we're really after. So what we need to do is write a formula that tags these names. Now, Excel doesn't have a formula that can distinguish between a name and distinguish between a place like Austin, Texas. So right here, I have to come up with a formula. Let me blow this up a little bit. That says true. This is the value that I want it to return for every name. And this is what a Boolean formula is. A Boolean formula is a formula that just returns true or false as its answer. So if I type in equals 1 equals 2, this basically says, does the number 1 equal the number 2? And the answer to that is false. And that's the Boolean expression return output that it gives me. Alternatively, if I said, does 23 equal 23, it would say true. And if I said, is 12 not equal to, this is the not equal sign, 23, it would also say true, right? So one of the things I noticed is that, this cell is blank and this cell is blank. And so for each name, you could sort of, the pattern is blank cell, name, blank cell. Blank cell, name, blank cell. And so we could write a formula right here that says this here is a name if 2 cells above it and 2 cells below it are blank. So I could say, start off by just taking one cell, and I could do A5. Is A5 equal to blank? And the blank is represented just by 2 double quotes. And the answer is yes. Now this doesn't really help me. I can copy and paste this. Oops, sorry. Let me copy and paste this real quick. Actually, I just was typing too fast and did something screwy, so let me just do that again. So this says true here. If I copied and paste that down, actually that works really well. So as you can see, it's returning the true value only for elements that have a name in the column. So this is exactly what I want to happen. I'll zoom back out a little bit, and I'll take this formula and copy it all the way down to the end of the data. So now I have Excel has tagged the information that corresponds to good names. So all I have to do now is just sort it, and what it did was brought all of the names together right here. Now, these formulas got all messed up because the references got messed up, but I don't really care now because all of the names are grouped together. So I can delete this, and I can delete this up here, and then I can delete all this stuff down here. And right now I have a very clean list of names, which is great. But I don't just want a list of names. I want a list of names that look like this. Now, I'm going to go through this really quickly because I've already taken 45 minutes of time, and I want to make sure there's lots of time for questions at the end. So so I've showed you some Boolean formulas. The text formulas I'd like to show you right now are these: left, right, and length and find. So what we're looking for here is a pattern that will allow us to pull out the first name. What is the pattern, I would say, is that at the end of every first name is a space. So what we want is a formula that grabs letters only up, starting from the left, only up to that first space. Now the left formula, I can point to a cell and then enter the number of characters. I could say 8 here, and it will grab the first name. It'll grab the first 8 characters, which is what I want it to do. But unfortunately, that formula won't work for all of the other cells because not everybody has an 8-character name. So instead of the numeral 8, what I would like to do would be to have a formula that returns a number representing the position of that space. So I could do find here, and what find will do, I pointed to this text, and I could ask it to look for a space. And so this number, find A1 comma space, it will return a 9, I guess. Oops. Oh my goodness, now why did that not work? That's embarrassing. I'm sorry, I got the arguments in the wrong order. If I put the space first and then within text A1, it will return a number representing where that space shows up in that cell. And that number is 9. And so the number 9 gets passed to the left formula, and in that case, we'll take the first 9 letters of that name. And then if I copy this down, the find in the left function does the exact same thing for all these others. So for John Smith, the find function finds that the space is the 5th character. It passes that to the left character, and then grabs the right 5 most characters, which in this case would be John all the way up to the space. Okay, now I said that I was going to finish doing Michael, Milton, but I have already taken up a lot of time, and I want to make sure that there is time for questions. So I apologize for running a little bit over, but it appears that we still have about 10 minutes to field some questions.
That was great, Michael, especially that last thing. I've dealt with that so many times. And, yeah, people, one person was asking about what you just did. Why would you not split the text in those into 2 separate columns and do it that way, which is usually what I end up doing in Word or something really awkward.
Sure. So there's a function inside of Excel that will allow you to pick, it's not a function, it's actually something in one of the menus. And I'm honestly not sure where it is inside of Mac, the Mac version of Excel. But it will let you pick it will let you pick a delimiting character, like a space, and it will automatically take the data inside of that cell and break it into columns wherever there's a space. So yes, you could absolutely do it that way. The reason I show you to doing with the formulas is that I think in my experience it only wants single character delimiters. So the way I just did it is actually more versatile. So say like, there are, instead of having Roderick Janes, let's just do something really gross. Let's just say we have $5 signs or 5 pound signs right there. Instead of looking for a single delimiter, you could just type in 5 pound signs, and it will do the same thing. Actually, I need to trim that character on the end. Using formulas, what you're describing is an excellent little shortcut. And using formulas is just a more elaborate way of doing it. If your data is more elaborately messy than than can be handled by those menu items, then you would want to use a combination of text formulas using left and find. And these text formulas, depending on the complexity of your mess, can get really, really enormous. As you layer complexity.
But what happens if you have names with hyphens and 3-part names and the rest of that, as we encounter all the time now? Can you easily come up with a formula for that?
Sure. So basically, here's I just showed you kind of an idealized situation. Right. Here's a more realistic situation. So let's say you want to extract first names, and what you have is something like this. And let's say you've got 10,000 variations on this. There's a bunch of different patterns here. One of them, this one, you could extract the first name using a technique like I just described, which is delimiting off of, delimiting off of the space. You could also do that here, but it would give a different outcome because there's different numbers of spaces before the first name. And this has no space before the first name. Yeah. So we have three kind of distinct patterns here. And so what I would do if I had a really large list that had a bunch of this kind of stuff would be to do everything I can to create Boolean formulas to try to isolate those different types of patterns into different groups, because you would use different functions for those different groups. So again, one of the things you need to think about when you're thinking of cleaning messy data is, how many, you're lucky if there's a single pattern that you can write code for that will, in one fell swoop, pull everything out, like in the idealized example I just showed you. But it may be that there's 3 or 4 or 5 different patterns. And so in that case, the first thing you'd want to do would be to create Boolean formulas, that try to put these different groups into buckets. So for example, if I had 100,000 people in my list whose names started with the honorable, I could just write a formula that says left VH. And that would, actually, that didn't work either. That would be left 5, I'm sorry. I could create a formula that basically tagged true for all of the ones that have the honorable, and maybe I would want to write a custom formula for that group of mess. Does that make sense, Catherine?
Yeah, that does make sense. That makes a lot of sense. So how do we learn how to think like you? That's just kidding.
Oh my goodness, that was such a transparent plug there. I'm not even going to.
No, I honestly, as I'm watching you do this, so. In a minute, I want you to talk a little bit about R, but first, Daryl is asking a question. Would you happen to know a formula to split time and date if it were in the following format? And he has a couple different formats there.
Okay.
First time is 1:54:33 p.m. October 28th, 2009, and then, or if you want to see the chat room. And then the second one, where did it go? Is just instead of writing out October, it has it at 10/28/09. So
right. So there are a few things.
You isolate the pattern, or you identify
right.
the pattern.
Oh, you're getting into kind of this is an important question, and in fact, I was thinking about devoting an entire chapter to this with Head First Excel, but right now, the learning for this particular topic is buried in as part of another chapter, and I was thinking about doing a whole chapter on this. As the person who asked the question probably realizes, dates are represented as integers. Like there's a single very long integer that represents a date and a time. So when you have text that you want to represent as a date, you need to figure out like how to get that text into the formulas that spit out the numerical values that Excel sees as a date. So, I mean, whoever asked the question, I'm sorry I didn't catch your name. Please email it to me, and I'll write a blog entry about like answering those specific questions. But it's kind of I couldn't actually get what the date was.
Okay, that was Daryl, and he said, okay, he will. So great,
yeah,
thank you.
So basically, just real quickly, I mean, there's a formula called date value, and this is I'll just write it out. I mean, that is sort of the entryway of taking text and piping it into a date. And so my general approach to solving a problem like that would be to use the text formulas like left and right to extract elements that could then be passed to a date value formula and then become a date. You know, in Head First, I could write a little diagram that would make this all seem like a lot less complicated. But you know, there's just this sort of intermediary step because it's not just what I've been doing is just pulling text out of text fields. But when it comes to creating dates, you have to pull text out of the text field and then pass it through a function that will tell Excel that it needs to return the numerical value that's represented by the date. So that's a whole lot of I can't answer question like this, but send it to me and I'll write a blog about it because it's painful, and I've had pain. I mean, I still have to look at the help stuff from time to time to make sure I understand how the data works because it can become a pain.
Yeah, it's definitely painful. I think a chapter devoted to this would be great.
Do you? Okay.
Yeah,
okay.
But I'm not your editor, so. A lot of people have been asking about R, and I know that we're almost out of time, but, you know, I'm an English major, and I think there are some others and some philosophy majors in this webcast, and I just want to know a little bit what R is exactly. Can anyone use it? Does it work in Excel? Can you pull data from a SQL database with it? You know, just a little bit. And I want to thank everyone, too, all the people who have supplied the great links to R tutorials and other information in the chat room.
Good. Yeah, there's one of the tutorial I used is called Quick R. I think it's like quick-r.org, and that probably popped up. That's a really good R tutorial. And also, if anybody pops off shortly, I just want to say how sincerely much I appreciate your time. So now I'll answer the R question. R is an open source project that was created by some statisticians in New Zealand, and it has taken the world, or at least the statistical and scientific computing world, by storm. It is open source, it's free, and it has an enormous amount of user-contributed packages from a bunch of different fields. It's very different from a spreadsheet. The difference that most people will notice off the bat is that you're not looking at your data all the time. You're loading your data, you don't see it, but you write code to have operations conducted on it. It's a different way of thinking using the command prompt, but it's something that I think is really worthwhile learning. It is much more powerful than Excel when it comes to creating data-based visualizations. So for the English major, and I'm a philosophy major, and so is my editor, for those of us, like the single most compelling reason to learn R would be to get into some of those really advanced visualizations. It's just so much more elegant, so much easier to control. I put a whole bunch of visualizations from R in my book, and Head First Data Analysis has kind of a crash course to R in it. That power is just breathtaking. I mean, I was amazed at it. Also, when it comes to cleaning up data, R has a full-blown regular expressions engine, and regular expressions is a kind of sub-programming language that is where the most powerful data cleaning is. Like if you took the best data cleaners in the world, they would all be using regular expressions because that just affords you the most power. It is not an easy program to learn how to use, and that's one of the problems with it, and I hope that 10 years from now, the R project itself and perhaps some material from O'Reilly will make it easier to use. It's just one of those things that generally the ease of use comes the power comes at the expense of ease of use. But if you spend a lot of time using data, I would suggest that you learn it. In a past life, I would deal with really, really enormous spreadsheets, like several 100,000 lines, and have Excel run operations that took an hour or more, and I would just walk away and let Excel think. And those types of experiences, it's like I really needed to be using something more powerful than Excel for that kind of for dealing with that quantity of data. So, I could say a whole lot more about R. I think it's very well worth your time. I've only learned R in the past year and a half or so. I think it's incredible, much more powerful than Excel. It doesn't do quite as well at formatting data and making pretty reports like Excel does, but the two programs aren't even trying to copy each other in that regard. And to answer your question, Catherine, there is a package that allows you to use R functions from within Excel. It's not one that I've used before personally, so I can't recommend it, but it is possible to integrate the two platforms if you want to do that.
Okay.
Does that cover it?
That was great, and I think we're running out of time. I know everyone has tons of questions for you, but we're getting a little short on time. So I want to say, first of all, thank you very much. I do want to ask you when your Excel book is coming out.
It is. It's too early for a date for the Excel book, but it's going to be early next year. I mean, it'll be.
Okay.
I'd love to have it out in February or so. I'm going to put up my email address one more time.
Great. I was going to ask you to do that.
All those questions you have. Whoops, there it is. All those questions you have, just send them to me, and I'll if I get enough of them, maybe I'll create a blog entry or an FAQ or something like that.
That'd be great. That's awesome. And so I want to thank everyone. I will have a recording of this available in a couple formats. You can watch it as a video, or you can watch it in the WebEx viewer, which gives you the benefit of you seeing the chat room and everything else. So Michael's blog is, where the heck is your blog, Michael?
It's michaelmilton.net.
Okay.
It's not as active as I'd like to say, but maybe if people send me good questions, there'll be a lot more exciting content up there.
Okay. Well, it's hard to keep a blog while you're writing a book, and I think the book probably comes first. So I'll send everyone a link as soon as the recording is available. And I want to tell people, if you want to keep a copy of the chat room, the chat transcript, do this now as I'm saying it, because people always tell me I close out the window too quickly. You just copy and paste it into a text file. So if you're on a Windows PC, you can click in there and do select all. If you're on a Mac, let me see, for some reason that function isn't available, so you actually have to copy and paste it, which is really irritating, but go ahead and do that. I also always keep a copy of it, so you can email me at webcast@o'reilly.com, and I'll be happy to send you one, so don't worry if you don't get it. And we have a discount. I know we've said this before, which is the numeral 4 and CAST, forecast. Thanks, Marcy. That will give you 40% off your book order from O'Reilly. It's actually an amazing discount because we don't offer it very much. And I think you'd be hard-pressed to find a similar discount anywhere else. So you can get Michael's book or any other book, the regular Expressions book if you want. And just feel free to shop. And that's about it. So thank you, Michael. Thank you, everyone. And I'm closing out the meeting now. Thanks, guys.
Okay. Bye-bye.
Bye.